We've finished plan 1, we're up to plan 2 now. We're going to get it steering and we'll get it driving. We're going to build the rear axle, front crank, steering column, and we'll make a steering wheel. Let's get over to the plans. Plan 1 has given us a complete chassis. Plan 2 will give us our drive line, steering column. Here's the breakdown of the parts that we're going to be making. We're going to start with part number 15, the rear axle. We're up to drawing 4. Our steering and drive line components. We'll be doing some broaching, keyways, and also some lathe work. So we're going to use a mill and a lathe. However, we'll also show you how to do it without those machines by hand. Part number 15 is 20mm round bar. It has to be 670 millimeters long. We have M6 by 15mm long holes at each end. That's to hold the wheels on. And there's also reference measurements for our keyways. After cutting, we need to deburr our piece. Then we can mount it in our 3-jaw self-centering chuck. We need 25mm stick out from the chuck. Center drill to initiate the concentric hole, or it won't drill concentric in the center of the bar. Set graduation to 0 on tailstock barrel for accurate drilling depth. This is important for our tap depth clearance. Using a 5mm drill, drill in 20mm deep to allow our M6 tap. Initiate the tapping on the lathe so you get it square and accurate, and then we can finish by hand. We're finished on the lathe now, we can move over to the mill. There's various ways to set up on a mill. We've used V-blocks, clamps and a vise. Find the shaft center for our 6mm keyway, and we use a 6mm slot drill to plunge and cut our 3 slots as per the drawing, and don't forget our cutting fluid. The last step is to finish the manual tapping on the ends of the axle. We've just finished machining our keyways and we've drilled and tapped. So we'll show you a method now without using machines. With our 20mm bar, we need to find the center. We've got a center finder, place it, mark it, move it 90 degrees, remark it. That will find your center. The other way is we get a ruler, half of the 20mm OD, 10, and we remark it at 90 degrees to each other. I've checked the drill hole size for an M6 thread. It's M6 by 1. We need a 5mm drill. I've squared our piece up to the vise. We also have a cordless drill that's got a spirit level. So to do it by hand, you need to make sure that orientation is correct in the horizontal plane and also left to right orientation. It's a 15mm depth, but we're going to go to 20mm. We've got our drill and tap set, and we'll also be using cutting paste. A good trick is to use a little bit of masking tape. So I've measured 20mm in from the tip of the drill. It's only a 15mm hole. Then we use that as our depth gauge. We've done our M5 hole for our M6 by 1 thread. The taps come in a kit with numbered drills to match. The taps also come in starter, intermediate and plug. The starting thread doesn't actually start to cut until down here. The intermediate starts to cut thread here. The plug you can see is right up near the nose. So one thing in mind is you need A, cutting paste, B, don't go too far with it, because if this jams up against the end of the hole that we've already drilled, you'll snap the tap through here. Then you'll have problems getting it out. You'll need easy outs, you may need to spark erode it, etc. It's a big problem. We've drilled our hole 20mm deep. We only need 15mm of thread. However, on the beginning of the tap, this area here won't cut thread. That is 20 millimeters, so we don't go up to the texture line. When we put the tap in, you need to make sure it's seated properly. We keep everything square, and I've measured and marked a depth where we stop. One full turn, 360 degrees, and then back off quarter of a turn to remove the swarf. If the swarf builds up, it may block, and again, it might break our tap. I'm finishing with the plug tap. There you can see the swarf. We then need to get in there with the blower and clean all that out before we try our bolt. We're up to part number 16. It's one of 20mm round bar, 225mm long, and we have 3 keyways at 30mm long in each keyway. The end keyways need to be 180 degrees opposite each other. So if we don't have a mill, we can do it by hand with our double grub screw method. So let's go over to the mill and we'll start keywaying. Using an end mill, we do each end of the crank axle opposed 180 degrees to each other. And then we finish with a slot drill in the middle. We've finished making our keyways for our crank. Each of the ends have to be at 180 degrees opposed to each other, so we get the correct orientation for our pedals. If you don't have a mill, get your 20mm round bar, cut it to 225mm long, and later we'll show you how to do our double grub screw method. This is a rear axle that we previously made. The hubs here have been done with 6mm keyways. The keyway gives you the ability for adjustment in and out for alignment on the chain. Also, it's a positive engagement, it won't slip. If you don't have access to a mill, to do our 6mm slots, there's 3 in the rear axle, 3 in the front crank. The other method we can use is to drill and grub screw into the axle, however you get no adjustment. There's a third method where we can weld the hub to the axle, however you lose your serviceability. We won't be able to change sprockets or any worn bearings. Therefore, you've got to cut the welds and remove the end caps. We're up to our drive hubs, part number 17 and part number 18. Part 17 is 5mm plate steel. We have a 20mm hole in the center, and we've got 3 holes that align with our hole centers on our wheels, so it drives. Part 18 will be machined and welded to part 17. So you can see that this is quite critical to set up and align. We've got our 5mm steel plate for part number 17. I've cut out the template because it's 1:1 scale, so we can use this to center punch our 4 holes, and then we can start the cutting and the drilling process. On our pedestal drill, we can go straight to a 6mm drill because we've got the power to drill through it. If you're going to do it by hand, a cordless drill, start with a pilot drill size, 3.5, 4mm, then you go to the 6mm. So we'll do these 4 with a 6mm drill bit. The center hole we have to drill out to a 20mm size for our drive shaft. This is a reduced shank drill bit, 20mm, 13mm or 1/2 inch shaft to go into our drill chuck. If you do this manually, you're going to have to go up incrementally every 3mm in your drill size up to 20mm. Please be careful, because if it kicks, you will hurt yourself. Another way we can finish off this round face is on a linishing attachment. We're up to part number 18. We need 4 of. It's 35mm diameter steel round bar with a 20mm hole center. On the drawing, it has a keyway and a grub screw. When we've finished making part 18, we'll weld it to 17 and we'll create the hub. We can then put a keyway with a grub screw. If you don't have the ability to do a keyway, we can do a double grub screw method to make sure it locks on the axle. This is our 35mm solid round bar. First of all, we'll show you how to do it on a lathe. We need to face off our round bar to get it square and flat so that the outside face, part 17, can be welded and it's square and flat for the wheels to be mounted. Center drill the middle of the round bar, then in incremental drill sizes go up to 20mm. Finish our internal hole with a boring bar and then part off to length as per our drawing. We've just finished making our part on a lathe, but we'll show you another option how to do it now. First thing we're going to do is measure in 20mm, cut that off, then we find our hole center and we'll take it up from a small drill size up to the 20mm hole. As you go up in drill sizes, you should slowly reduce the RPM so that you don't overheat the drill tip, blunten it, and then you'll have to resharpen the drill. So you should always drop your RPMs just a little bit the bigger the drill size you go. We've got part 17 and part 18. To get the alignment, we're going to use some 20mm round bar, slide the two parts together and weld around it. We've welded up a pair of rear hubs. The next thing we need to do is broach a keyway. We're either going to use an arbor press or a hydraulic press. We're going to use a hydraulic press to do our broaching. Insert the bush and insert the broach, and don't forget to lubricate. The back of the broach should be perfectly vertical. There is a taper on the front face. After the broach has passed through the first time, reset with a shim to get a deeper cut and then push it all the way through again for a second pass. We need to do our grub screw now. So we have to measure in 10mm from the outside flange and make sure you put the grub screw directly over the center of the keyway. Then what we'll do is we'll do a 5mm drill and we'll do a 6mm by 1mm pitch tap. If you don't have the luxury of a mill to do a keyway, the other way we can do it is grub screw top and bottom. So we've set the hub 50mm in from the end of the axle. You can use a transfer punch, it's a 5mm transfer punch, to go into the 6mm hole. With this method, we can securely drill down into our bar about another 5 or 6mm, and the grub screw will plunge into that hole and lock, which will also lock our drive hub, both top and bottom. And we need to repeat this process throughout 3 times on the rear axle, 3 times on the front crank. So that's locked in nicely. It's good for drive. Don't forget to do the bottom. The last method to secure the hub to the axles is to weld around the inside face of the flange here. Don't weld the outside because that's where the wheel's going to mount. We do 2 welds, one here and one here, and you have to be repeating that process 3 times on the rear and 3 times on the front crank. We're up to part number 19. We need 2 of, they're the drive hubs for the front and the rear sprockets. It's 45mm diameter solid round bar with a 20mm hole center. We will be doing some broaching for a keyway. We've also got M6 threaded holes. These will bolt the front sprocket and the rear sprocket to the hubs. They'll also be grub screwed. We've got our 45mm solid round bar for our rear drive hubs. First thing we're going to do is go to a lathe. We'll get the hole center, and then we'll take it out to 20mm for our axles. We'll then go to a mill. We'll do our 3 M6 threaded holes. Lastly, we'll do a broaching, either as an arbor press or a hydraulic press. Use a center drill, and then we'll go up in our incremental drill sizes. But this time we'll finish with a reamer, not a boring bar. Part off to length, and then we'll go to the mill. Set up on the mill, and use a 10mm centre and edge finder to find our pitch circle diameter, or PCD. Using our digital control system, we have a PCD function to space our 3 holes accurately. You can countersink the hole, then drill and tap. Using our PCD function allows us to drill and tap with precision. This time, to do the broaching, we're going to use an arbor press. The procedure is identical to the hydraulic press method. The arbor press gives you very good manual feedback. You can feel the resistance as it notches and removes swarf. We've finished making this on the mill and the lathe, and we've done some broaching for the keyway. So now we'll show you how to do it by hand. You can cut your template out off your plans because they're 1:1 scale. The template will give us our hole centre for our 20mm hole. It will also give us the PCD hole centres for our M6 threaded holes. This is crucial for our front sprocket and our rear sprocket. These are ones that we've laser cut, so they're already done to size, and a 15 and 32 tooth sprocket. However, you can also use recycled old kiddies push bikes or an adult push bike and cut the gears off to reuse those on these hubs. We've marked our hole centres. We're going to drill using a drill press for safety reasons. The centre will go up to 20mm in diameter with the drill. We then have to drill 5mm holes on our 3 outside holes, and then we'll have our 2 grub screws that we're doing on the outside face. Each of these holes are at 120 degrees to each other. So to make sure we've got enough material, what we're going to do is go between the 120 degrees. We're going to have 2 locking points. So we're going to split the difference between these 2 holes. We've done all our drilling. The last thing we need to do is run our M6x1 tap through the 5 holes, and this piece will be complete. Just one other thing quickly is I'm using an intermediate tap here on all 5 of these holes because the holes are open, so the tap can go through, whereas previously we've used a starter plug intermediate. So on this case, we could get away with using an intermediate only. We've finished manufacturing part number 19. This is our rear sprocket, part number 25. We've used a mill and a lathe to manufacture this part. We've also used broaching, and we've laser cut our sprocket. So this is perfectly manufactured. This one here we've salvaged from an old push bike, and we've handmade our hub. So you can work out your hole centres on each, subtract the difference, that way you've got equal symmetrical distance. Then you can do a transfer punch and bolt the 2 together. Thirdly, this one, again, diameter differences, work it out, centre, and you can weld these 2 together. So that's 3 different ways that you could manufacture your hubs and your sprockets. We're up to part number 22. We need 2 of. These are the cranks made out of 5mm thick plate steel. We've got 2 holes to do, one for the 20mm solid round crank. The other is to go to our pedal. Here's a crank that we've made previously. It's been laser cut, it's ready to go. So we're going to do this one by hand. We've cut this out of our plans because it's 1:1 scale. So we can mark it, centre punch, cut, drill, and then we'll be ready to mount it to our hub. With our holes on the crank, we've got one that does the crank axle, that's 20mm. The other one can be varied depending on the diameter of your pedal. This is a junior pedal. Then you've got other size pedals for adults, etc. So you need to make sure that these diameters will match and fit onto your crank. So we've finished drilling our holes for our pedal and our crank. We're now going to taper it and radius the ends, just so that the kids don't bang their ankles into the square edges of our crank. We've finished making our crank. We can now weld these two together using our crank axle as a jig for alignment. Then we can broach through. We can also weld our pedal to the crank, or you can use a nut. Bear in mind, one's a left-handed thread, the other one is a right-handed thread. We've finished welding our pedal and our crank hub to the crank. So now we can trim it. Just make it a little more user-friendly so that you don't pick up any edges, etc. The last step is to do our grub screw, both top and bottom. So we can measure, mark, drill, and tap. That will lock it on the crank so it doesn't slide off, and it's just to make sure it's safe. We've got our cranks hubs welded together. We now need to fit them to our crank axle. We're going to do that either by keyways, or we can use our double grub screw method. But prior to that, you'll have to transfer punch down through the hole to find the hole center. If you can't do that, use a grub screw down into the hole to witness mark on the crank, and then drill down about 4 or 5 millimeters to give it a seat where the grub screw can locate. I hope you're enjoying yourself. You've learnt plenty, we've covered lots of skills, so I'll see you for another episode.